Okay, we have started with the integration techniques, and in the previous sessions we have discussed about integration by substitutions and integration by parts. So now let's start with integration by partial fraction. Let's start with the other four cases of integration by parts. How we will do is, suppose all factors in the denominator are linear and not repeated. Linear and non-repeated. Where linear means a thing which is going on like ax plus b and nothing is only 1. Their power is ax plus b. Power is only 1. Suppose I say x square or something, that would be more into quadratic. We will do it in the other cases. So as of now, we will talk about the case where all the factors in the denominator are linear and non-repeated. They are not repeating. To each linear non-repeated factor ax plus b, there is a correspondence of fraction of the type a upon ax plus b, where a is some constant. We will add into it. How to solve it and how to do it? Let's do it. Let me explain. Okay. Suppose the question comes like this. Integration of x upon x plus 1 and x minus 2. We can see clearly x plus 1 is one of the function and x minus 2 is another function, and they are not repeated. Suppose it would have been x plus 1 like this. It is repeated, but not this. I think it's clear. Right. Now, if denominator consists only of linear function, I'm writing so that is easy for you to understand. Linear functions, or I can say linear, it would be easy if I say linear factors, the term which you are used to. Linear factors, then each factor occurring exactly once. Huh? Now, what I am saying is how we will do it, how we factorize, because we have to do it by parts. X upon x plus 1. Please see carefully what I am doing. X upon x plus 1, x minus 2. I will write that the two factors a, x plus 1, plus b, x minus 2. I previously told you a and b are constants. Now, if I will solve it, this is equivalent to, I take then LCM, x minus 2, it would be a, x minus 2 plus b, then it would be x plus 1. I think it's clear. Plus 1, x minus 2. What I have done? I cut this into this, then it remains x equals to a, x minus 2 plus b, x plus 1. I think it's clear this is stat. No. Suppose if x equals to 2, I am keeping x equals to 2 from here. X minus 2, I am keeping it 0, then x equals to 2. I am keeping or x plus 1 because 0, x equals to minus 1. I will consider x as two values. One is plus 2, another is minus 1. Is it clear? So, again now, when I am keeping x equals to 2, put the value of 2, x as equals to 2 in this. 2 equals to a, 2 minus 2 plus b, 2 plus 1. We are solving, or we are putting it so that we can get the value of these constant a and b. I will solve it, then by this we can see b comes out to be 0, This comes out to be 0 and right, b comes to be 3. Then b is equals to 2 upon 3. I think it's clear. Now, if x equals to -1, in that case, -1 equals to a -1 -2 plus b -1 plus 1. Over here, it would be 0. And then we can get easily the value of a, 1 upon 3. I think it's clear. Now, x, we can write x upon x plus 1, x minus 2 equals to 1 upon 3, the value of a. Whatever the value we have to see, we will put it in this. We are now putting the value of a and b in this equation. 1 upon 3, and it is x plus 1 plus b is 2 upon 3 upon x minus 2. Now, integration x upon x plus 1, x minus 2 equals to, we are saying, with respect to x, we are saying 1 upon 3 upon, I can say like this, 1 upon 3 upon x plus 1 upon 3 x minus 2 with respect to dx. We have to integrate it. We can solve this. 1 upon 3 will be kept outside, 1 upon 3, and 1 upon x plus 1. Integration of it would be log x plus 1 plus 2 upon 3. It would be log x minus 2. I'm keeping it in this way. If I plus c, if I bring 1 upon 3 outside, it would be 1 by 3 log x plus 1 plus 2 log x minus 2 plus c. I can even write it 1 upon 3 log x plus 1 plus log x minus 2 power 2 plus c. What I have done? Something which is in multiplication to the log, that will come in the power. And so next instead, rather than keeping it 2 here, I brought it here. I think it's clear. Is it? Okay. I think we are done with this. So the answer is 1 upon 3 log. I can write a log because they are in plus. I can write it in multiplication. I can say log x plus 1 x minus 2 whole square plus c is your answer. I think it's easy. What we have done, let me tell you again. Simply, we have to each non-linear repeated factors corresponds to the fraction of the type a upon ax plus b for each corresponding fraction. Now, in this, there are the two factors. So, what we have done, we have taken the two constants a and b, and we have kept a upon x plus 1 and b upon x minus 2, and then we have solved it. Whatever the value we get it for a and b, we have kept in this equation and solve it further, and we get it this, and we have integrated it, and we get the result. I think it's clear. Let's do some more questions based on it, so that will be easy for you to understand. And I will suggest you to do the practice and do it by yourself. Now again, first see, this question can be simplified. Can I write x1 minus x square Yes or no? Then I can further solve it. We know a square minus b square. A square minus b square, a minus b, and a plus b. So same thing is there. So I can solve it. Chaliye. It would be 1 upon x, 1 minus x, and 1 plus x into dx. Now we can say, you can observe that the denominator of the integrand, the denominator of an integrand consists of linear non-repeated factors. They are non-repeated factors. X, x minus 1, and x plus 1. The three of them are the non-repeated factors. And when is the non-repeated factors? Is directly our case 1. I just explained case 1, where we have to keep a upon whatever the factors plus b upon whatever the factors, like this. Now, so therefore, I can write 1 upon x, 1 minus x square, or simply I can say, I can write x minus x cube equals to a upon x plus b upon 1 minus x plus c upon 1 plus x. And they all are non-repeated and linear. Now solve it. Again, take the LCM. X, 1 minus x, 1 plus x, right? It would be a, 1 minus x, 1 plus x, plus b is x, 1 plus x, plus c as x and 1 minus x. I think it's clear till that. Can I write it like 1 upon x minus x cube? We can cut this to equal to this. So what comes, what left? I can say 1 equals to a, this minus x and x, I can write 1 minus x square plus b x, 1 plus x plus c x of 1 minus x. Now, what can be the value of x? I can say x can be 0, it can be x can be 1, x can be minus 1. If I keep all these three values for x and see how we can solve it. If, because I need the value of a, b, and c, in this way I can calculate. If x equals to 0, it would be 1 equals to a, 1, plus b, 0, plus c is 0. We get a equals to 1. We have calculated the value of a. Now, if ax is equals to 1, in that case, 1 equals to a, 1 minus 1 plus b, 1, 1 plus 1 plus c, 1, 1 minus 1. We can easily get the value of b equals to 1 by 2. I think it's clear. Now, if x equals to minus 1, in that case, 1 equals to, in a, 1 minus 1 whole square plus b minus 1 plus, sorry, it is 1 plus minus 1 plus c minus 1, 1 minus 1. Solve it. You will get it 1 equals to, for A is 0, for B is 0, for C is coming out to be -2. Minus plus and 2 and -2, which shows C value is -2. I think it's clear. We got the value of A, B, and C. Now, therefore, 1 upon x minus x cube would be 1 upon x plus, I have kept the value of A as 1 upon it. And in the B, it would be 1 by 2 upon 1 minus x. I can say half. Minus, I have kept the value of minus because it's minus half. Half 1 plus 1 plus. I think it's clear. Now, we got the value. I can integrate 1 upon x minus x cube equals an integration of, with respect to dx, it will be integration of 1 upon x dx, 1 upon 2 integration 1 upon 1 minus x dx, minus half integration 1 upon 1 plus x dx. Can I do this? Now, integration of half would be log x plus half log 1 minus x. And if you remember, in previous sessions, I explained clearly, if something which is multiplying by x, this was a special formulas which we have done in the previous session, it is -1. So what it would be? It would be divided by -1. Minus half, and integration of is 1 plus x, and in this is x is multiplied by 1, which is divided by +1. So no need to write it as a +1, but -1 was important to write. Now the answer becomes like log x minus, this minus sign will come outside, half log. Can I take log as a common, or in the next step? Don't get confused. Okay, minus half log 1 plus x. Now, log x is there. I will take the half outside. It will become log 1 minus x plus log 1 plus x. I think it's clear. I can write it like this also, log x minus half log, when they are in a plus sign of the log, the formula says 1 minus x multiplied by 1 plus x, right? Or I can say 1 minus x multiplied by 1 plus x, it becomes log x minus half log 1 minus x square. Right? And when it is half outside, can I bring it inside, and I can write like log 1 minus x square to be under root, or I can say in the power half, become under root. And then when it's a subtraction sign, and plus c, we can write it everywhere after integration. Right? Now we are solving it. Log is minus x upon 1 minus x square. I think it's clear. Plus c. क्योंकि minus का sign है, it means it's a division. X, if it would have been plus, then we have multiplied it here. Now it's a subtraction. It means x divided by whatever the factor is there, or whatever the variable is there. X upon under root 1 minus x square. So this becomes your answer. Clear to all? Okay, now we have the two standard formulas for solving it. If something like 1 upon x square minus a square dx, right? In that case, what we will do is, we will write log x minus a and x plus a. Because when we solve x square minus a square, can we write x minus a and x plus a? So what we are doing, we are dividing log divided this one divided by positive. I think it's clear. And we will bring 2a outside. 1 upon 2a as an outside factor plus c would always be there. If suppose is a square minus x square, in that case, we will write 1 upon 2a outside, but in the log, it would be a plus x and a minus x. A square minus square, it would be a minus x and a plus x. Two things are there, but in that case, the positive things, we will keep it up. That's in the numerator. A negative one in the denominator. Is it clear? Okay. Let's do some questions based on it. Okay. X square minus 1 upon x power o plus 1. Okay, easy. First of all, let's, when it's something like this, we will first try to simplify it. I can see I can simplify it further. How can I simplify? I can write x square as a common. Because in both the cases, if I can bring the x square, it's easy. 1 minus 1 upon x square. I think you might have done these type of questions in 12th also. This become x square plus 1 upon x square. Yes. Now we see this would be good. The remaining one is 1 minus 1 upon x square and divided by x square plus 1 upon x square dx. And we know if we will 1 plus 1 upon x whole square, what it would be? X square plus 1 upon x square plus 2. I think these sort of formulas you might have learned in your lower classes, 11, 12th, or maybe in 8, 9, 10th, 11, 12th, like this. Now suppose I say put x plus 1 upon x equals to t. Then dt would be 1 upon 1x square dx. dt इसका क्या हो गया? इसका 1 and this would be minus 1 upon x square. I think we can calculate the differential. But if you want me to do it simply, again I will do it. I can say dt upon dx. It would be for x equal to be 1, and for 1 upon x it would be minus 1 upon x square. I think it's clear. And then I can write dx equals to dt upon 1 upon square, the way we want it. Okay, chalo, now we will write it in this question. I can say 1 upon x square dt. We can write e square minus 2 into dt upon 1 minus 1 upon x square. How we have written it? See, this is x square plus 1 square. We know x square plus 1 upon x square plus 2 is equals to, for this, is equals to x plus 1 upon x whole square. So I can say for x plus 1 t square equals to x square plus 1 upon x square plus 2. So I can say x square plus 1 upon x square t square minus 2. So over here, what I have done, I have just simply put this x square from here. I think it's clear. T square minus 2. Put the values, okay. And then I've seen this would be cut from it. The remaining one would be, I have to dt, integrate the dt upon t square minus 2. Is it clear? Or I can write it down in this way so I can integrate it easily. T square minus root 2 whole square. Can I write it in this way? 1 upon 2 root 2 plus, not plus, it's to be log, multiple log, t minus root 2 upon t plus root 2. From where I have written this? From the formula. I just explained you the formula above. No, I explained you the formula. This become like this. 1 upon x square minus a square dx. Can I write it? Just give me a second. I will explain you with a different color. It's saying 1 upon x square minus a square dx. And we know 1 upon 2a, whatever the a is, we will bring it here. And log x minus a upon x plus a plus c. When the question comes in this format, अब हमें clear हो गया, we got it clarity. This is in this form, so we can directly solve it. 1 upon 2a, a is root 2 log t minus root 2 upon t plus root 2. I think it's clear. I can now substitute the values 1 upon 2 root 2 log in place of t. I will write x plus 1 upon x minus root 2, which would be divided by x plus 1 upon x plus root 2. Right? I can even write it, and plus c is always there. So we will write 2 root 2 log, if I will multiply by x in both the sides, it would become x square plus 1 minus root 2x divided by x square plus 1 plus root 2x plus c. If we want to write in the quadratic equation form, I can write it 1 upon 2 root 2 log x square minus root 2x plus 1 upon x square plus root 2x plus 1 plus c. This is your answer. I think it's clear and easy. Okay, one more question. 53, we will do it fast. Observe that degree of numerator is greater than degree of denominator. Which degree है 2 and this is 3. The degree of numerator is more than the degree of 2. In this case, what we will do? We will first of all simplify it by dividing it. I can say x square minus 1 divided 3x square minus 3x plus 4 divided. We know how to divide it. 3x square divided, it would be 3x square divided by x square first. Right? It would be 3x. Then multiply x square 3x square minus 3x. Solve it. This is minus, this is plus. By doing this, it will be cut. And you're remaining with the 4. So we can write it. 3x is this one 3x plus remainder is 4 upon x square minus 1. We can write this in this way. So integration would be 3x or I can differentiate it 3x plus integration of the 4 would be outside 1 upon x square minus 1 dx. Right? Now it's easy. For the 3x, you can easily integrate. It would be 3 outside and x square upon 2 plus 4 outside. And for this, we have the formula 1 upon 2a. A is 1. Right? Is 2a. log x minus 1 upon x plus 1 plus c. The same formula which we have done it above. This one. Okay? X square minus a square. Same formula. You have solved it. X minus 1 upon x plus 1 plus c. The final answer comes out to be 3 by 2x square plus it will become 2 log x minus 1 upon x plus 1 plus c. We can leave the answer over here as an answer, or even if it's a log, you can bring 2 over here also. Doesn't matter. This is a final answer. I think it's clear. Let's take the break for the 2 minutes and then we will come back to for the case.